In this video, we'll be solving a circuit that requires mesh current or loop or mesh analysis. So first, here are the steps. There's 4 simple steps: identify and label the meshes in the circuit, assign each mesh current to each mesh, apply KVL, solve the system of equations to find the mesh current, and in this problem, we'll be using passive sign convention, which means that if a current enters a source, that will be written as a positive voltage value, and if it enters from the negative value of a source like this, that will be written as a negative voltage value. The other difference is that if the loop that we choose for the mesh, let's say it's going this way, the way our KVL will be written is as IR, not negative IR, positive IR. Now, what is a mesh? A mesh is a type of closed loop that does not contain any other loops inside. So for example, this over here is a mesh, this is a mesh, and this is a mesh. However, if there was something blocking, this entire thing would not be a mesh. Instead, this would be a mesh, and this would be a mesh. Now that we have identified our meshes, 1, 2, 3, we can choose our current or loop directions. I want to choose this loop direction as going this way. I want to choose this loop direction as going this way. And I want to choose this loop direction as going this way. And this will be I1, I2, and I3. And now I want to start off with this 1 kiloohm over here. And this current will be going down over here, and there's no other currents interfering with it. So this will be written as 1 I1 plus it goes this way and it goes into from the voltage from the negative 12 side. So that will be written as plus negative 12 volts plus it goes in this way I1 while I3 also goes this way. And because both currents on the 1 kiloohm resistor, I3 and I1, are going the same direction, this equation will be written as 1 kiloohm times I1 plus I3 equals 0. So the first equation. And now for the second equation, we can start from here. And now for the second equation, I2 will be coming down over here. So this will be written as 2I2. And since it's not interfering with any other meshes, so there's no other currents opposing it or going or interfering with the 2 kiloohm resistor, it's just a plain I2 plus 0. You can write it like that. You don't have to, whatever. Then this current goes here and goes into the 12 kiloohm resistor from the negative side. So this will be written as plus negative 12 volts plus goes here and goes like that, while I3 goes the opposite direction. So because of that, this will be written as plus 1. Since they go in the opposite direction, they're opposing each other. This will be written as I2 minus I3 equals 0. And now for this third equation, we can see I3 going this way while I2 goes this way. They're opposing, so this will be written as 1 I3 minus I2 plus 1 I3 plus I1, and this enters from the negative terminal, minus I6 equals 0, and solving system of equations, we get our I1 to be 4.287, wait, 2857, sorry, milliamps, our I2 to be 5.1429 milliamps, and our I3 to be 3.4286. And now solving for V0, we see that the current is going from the positive node to the negative node. so V naught 0. So V naught equals 2 kiloohms times 5.1429 milliamps, and our V naught becomes 10.2857 volts. However, let's say this problem asks us to find the current over here, which I will call I naught. To do that, we can see that in this branch, there is a I1 going this way and an I2 going this way. So I naught, which is going down, while I2 is going up in the same wire and I1 is going up, the equation for I naught will become I naught equals I1 plus I2 negative, since I1 and I2 are going in the same direction, however, that is in the opposite direction of I naught. So I naught will become negative 9.4286 milliamps. And now for this problem, all of the currents are labeled and all the meshes are already here for us. So step 1 and step 2 are done. Now I just need to do step 3. Pretty simple. However, the only difference here is that we have a 2 milliamp. And our 2 milliamp is the same for, is I1. Since the 2 milliamp is a current source, and this current source will be going this way, and this way. So our I1, when it's left alone, is just 2 milliamps. However, if this was written as over here was the 2 milliamps, that would be a different story, but we are not going to focus on that right now. So just to reiterate, the only reason why this is a current source is because there is no meshes interfering with this, so the only current that it could possibly be is the I1. So now starting off with up here, this can be written as 2 kiloohms times I2, since there's not touching any other meshes. This goes in from the positive 12, so this becomes plus 12 volts. Plus it goes down here, while the I4 is going the opposite way, so this equation will be written as 2 kiloohms times I2 minus I4, since they're opposing directions, plus it goes to the 1 kiloohm, which is opposing direction with the I1. So this will be written as 1 kiloohm times I2 minus I1 equals 0. However, since the I1 is equal to 2, this is just be a simple 2. Now for our next equation, I3, this enters from the negative terminal, so that's a negative 6 volts. Plus it goes to the 2 kiloohms. Oops, that's covering it. It goes to the 2 kiloohms, while the I1 is opposing it. Since they're opposing currents, this will be 2 kiloohms times I3 minus I1, plus it goes down over here, while the I4 is going against it, 1 kiloohm times I3 minus I4 equals 0. For the next equation over here, we're going to start I4 from here. I4 is entering the 1 kiloohm, while I3 is going against it. So this will be written as 1 I4 minus I3 plus I4 is going this way while I2 is opposing it. 1 I4 minus I2 plus going down over here while I1 is opposing it. I5 is opposing it. 1 I4 minus I5 equals 0. And I forgot to mention over here, since will not be I1, it'll be 2. However, you can always use your I1 while writing the equation, but then sub it in for 2 later. Doesn't really matter. And lastly, we see I5 over here is left alone with the 1 kiloohm, so this will be 1 I5 plus going to the I1, which will be opposing directions with the I4, 1, I5 minus I4, plus going into the negative 12, so this will be minus 12 volts. So if done correctly, I1 equals 2, we already knew that. And I don't know if I mentioned this earlier, but we did not write an equation for I1 since I1 is already known, so there's no need for an equation. We only write equations for unknown values. I2 would be negative 1.0986 milliamps. I3 would be 4.0845 milliamps. I4 would be 2.2535, and I5 would be 7.1268 milliamps. And let's say I was trying to find the current over here in this branch. I'm going to call that I0. I0 is going down. I3 is also going down, while I4 is going up. I4, I0, I3. So this equation will be written as, since I3 is going the same direction, I3 minus I4. And this becomes I0 equals 1.8310 milliamps.